Hello guys, how are you all? I hope you are all fine. So this is the last part of this chapter, part 4 of real number maths, class 10 students. So basically there are 3 theorems I will explain. Okay, these 3 theorems are very simple, just you have to understand the theorem. Okay, basically it's a theorem, it is given in the form of theorem, but the knowledge you will get from this theorem is class 4, 5, 6 standard. Okay. So coming to the first theorem, what is the first theorem? Theorem 1.5 says, if let x be a rational number whose decimal expansion terminates. So basically what they have said, x is a what type of number? It is a rational number. Okay, rational number whose decimal expansion terminates. Okay, so that means let us assume 1.47 is a rational number which after decimal it terminates. Okay, now x can be expressed in the form of p by q. That means x you can express it in the form of p by q. So that means 1.47 can be expressed in the form of 147 by 100, as you all know. Now where p and q are co-prime, obviously they are not going to cancel to each other, so that means p and q are co-prime. Then the prime factorization of q, what is q here? This is our q. Then the prime factorization of q, that means if you do the prime factorization of 100, 250 is a 225 is a 5 is a. Okay, so and the prime factorization of q is of the form 2 power m, so that has to be in the form of 2 power m into 5 power m. Okay, where m and n are non-negative integers. That means m and n are non-negative, that means they must be positive integers or they can be 0 also, right? So yes, we have seen 100 can be written as 2 to the power 2 into 5 to the power 2. So that is what we mean by 2 to the power m into 5 power m. Okay, so the theorem states that if x is a rational number and it is terminating decimal expansion, then the denominator, when you write it in the form of p by q, the denominator will be in the form of 2 power m into 5 power m. Okay, this is the theorem all about. Okay, coming to the next theorem, it says x equal to p by q. It is given x equal to p by q. You can refer to page number 16 of your textbook. Is a rational number such that the prime factorization of q, when you factorize the q, it will be in the form of 2 power m into 5 power m. Okay, and m and n again are non-negative integers. Then x has a decimal expansion which terminates. Suppose 2 to the q equals to 2 to the power say 2 into 5 power 1. They may not be same. Okay, so suppose 147 again I am taking as p. So this is our p, and q is in the form of this 2 to the power n into 5 power n. So that makes it 2 to the power 4. 4 5s are 20. So they said if this is the scenario, then this number can be in the form of terminating decimal expansion. That means this is the reverse of this. So if you multiply 5 in both the cases, so denominator will be again 100. So whatever be the answer, you will write the 2 decimal places before that, since there are 100. Okay, so this is the just converse of this theorem. So in this theorem, what did they say? That x is a number which can be represented in the form of p by q, and q is what? 2 power m into 5 power n. Then q equals to, we are assuming that 2 to the power 2 into 5 power 1. So whatever be the value of q, if it is in the form of 2 power m into 5 power n, then it must be, when you divide the number, you will get the denominator or the whole number, you will get what? This is a terminating decimal expansion. Obviously, suppose if I take a easy number, say 12, okay, or 13 if I take, and it is only q is, okay, they are non-negative, so let us assume that this is 0. So in this case, let us assume that p is 13 and q is say 2 to the power 2. Let us assume it is 4. So when you divide 13 by 4, Obviously it is a terminating decimal expansion, because why? 4, if you take 25, if you multiply here also if you multiply 25, what happens? 25 fours are 100. Whatever you get the value, that suppose when you multiply this you will get an answer. So that means 2 decimal places before that you will put the decimal point. Okay, so this is the second theorem. Understood? Okay. Now the last theorem says, let x equals to p by q. Again, x equal to, it is given p by q, where such that the prime factorization of q is not in the form. Now they have mentioned that q is not in the form of 2 power m into 5 power m. Okay? Then x has a decimal expansion which is non-terminating and non-repeating. That means what? If it is not the scenario, suppose it is mentioned 2 power 2 into 3 power 1. So q basically what? 2 2s are 4, 4 3s are 12. Suppose you take a number p. P is suppose 100 by 12 if you do. So obviously you cannot make the denominator 0, right? So it will be a non-terminating decimal expansion. Okay? So that means what? If you divide with 100, so 12, if you divide this, so what is the value? Value will be continuous when you do this. Okay? To sum up the whole thing, did you understand this part? If q is in the form 2 power m into 5 power m, then the decimal expansion will be decimal. And if the q is not in the form of 2 power n into 5 power m, then the decimal expansion will be keep on repeating. We will not get a terminating decimal number. Okay? Let us take an example to understand this clearly. Okay, let us take 3 examples to understand the previous theorems. Okay? So before going into this, I want to tell you what is a terminating decimal expansion and non-terminating. Suppose 1.23 is a terminating because it ends here. But suppose the situation is like this, 4.373737 you are getting. Okay? So that means what? This is a non-terminating decimal expansion. Why? Because it is keep on repeating the same thing, right? So check the denominator. Denominator is 8. When you divide, 2 4s are 8, 2 2s are 4. So 8 can be written as 2 to the power 3. Is it in the form of 2 power m into 5 power n? Yes. How? It can be written as 2 to the power 3 into 5 power 0. Yes, because m and n can hold the value 0 and positive numbers. So this is a terminating decimal expansion. So how will you convert if they ask you to convert into decimal expansion? How will you do? A shortcut method. First method is to divide directly 17 by 8 if you do. And second method is what? You write 2 power 3 into 17. So to make it 10 to the power something, we have to multiply what? 5 to the power 3. So that makes it 5 to the 10 and power 3. So when you multiply 5 power 3, you have to multiply 5 power 3 also here. So when you multiply this, you will get a number. Okay? But here what will you write? 2 into 5 whole to the power 3. That makes it denominator 10 to the power 3. That means 1000. So whatever be the number, when you divide it by 1000. Suppose the number is 4297. I did not multiply, you multiply and find out the answer. Divided by 1000 when you do. So it will come 3 decimal places before. So that makes it 4.297. Okay. So that means what? This number is a terminating decimal expansion because it is ending here. Understood? Coming to the next question. Suppose when you see the denominator is, you don't have to factorize because it is already in the factorized form. So what is the denominator? 2 to the power 2 into 5 power 7 into 7 power 5. Other than 2 and 5, what is the form? If it is 2 power m into 5 power m. Other than this, if it is say 7 is there or 3 is there or any other number, 11 is there, such number when you see denominator other than 2 and 5, if there is anything else, 7, 3, 9 or whatever, so that will not be a terminating decimal expansion. You can directly write. Okay? If it is ending with 2, 5 or multiplication of 2 and 5, so it is not in the form of 2 to the power m into 5 power n. So the decimal expansion will be repeating and non-terminating. Did you understand why? Because it has 7. If it is 2 and 5, remember 2 and 5 together possible, only 2 is also possible, only 5 is also possible. Okay? So coming to the next question here, 210 if you factorize 3 sevens are 21, 70, 7 tens are 2 fives are. See, other than what does 210 contain? 2 into 5 into 3 into 7. 2 and 5 are there, but 3 and 7 are also there. So will it be terminating decimal expansion? No. Why? Because other than 2 and 3, it is not in the form of 2 power m into 5 power n. So that is why you can say that this is a non-terminating decimal expansion. Okay? So the exercise 1.4, all the questions you can do. So your homework will be exercise 1.4, all questions. So the first question they have asked, without actually performing the long division, state whether the following rational numbers will be terminating or non-terminating. So factorize the denominator. If it is in the form of 2 power m into 5 power n, then it is terminating decimal expansion. If it is only 2 power m, 2 to the power something, that is also terminating decimal expansion. Here we have seen we can convert obviously. If it is 5 power n also, 5 power any number, that also implies that this is a terminating decimal expansion. But if it is 2 to the power m into 3 power something, then it is not. Okay? If it is only 3 to the power something into 5 to the power something, so that is also not possible. 2 and 5, if it is there, if it is in the form of this, then only it is terminating decimal expansion, and others are not. In the second question, they have asked from the question number 1, those numbers which are terminating decimal expansion is possible, find the decimal expansion. So the same question, it is actually question number 2 from question 1. So this is question number 1, 2. First you have to write, since it is in the form of 2 to the power m, 5 power n, therefore it is a terminating decimal expansion, and you have to find the terminating decimal expansion. How? By using this method. Here what will you write? 17 into 5 power 3 means 125. You multiply this, divided by 1000 you will get. So 17 multiplied by 125, you do the multiplication, and divided by 1000 means what? 3 decimal places before. So in this way you have to carry out the calculation for the question number 2. Understood? Okay. Now the following real numbers, question number 3, the following real numbers are given below. In each case, decide whether they are rational or not. So if it is terminating, that means it is a rational number. Yes, we have already got this, that if a number is terminating, then it is obviously a rational number. If it is non-terminating, then we have to see whether it is repeating or not. If it is repeating the same number, that means it is also a rational number, because in class 9 we have got how to convert 1.47 bar into p by q. Yes, so it is also a rational number. But if it is non-terminating as well as non-repeating, so they are what? They are irrational number. Okay? I hope you have all understood. The entire chapter is finished here. I hope you have all understood up to this much. And until next time, I will be seeing you soon. So until the next time, keep watching MP Educations. Thank you.